Right, so the next principle is the Liskov substitution principle. So let me go ahead and create that file. So I'll do lsp.ts like that, and then let me just bring in the explanation. So basically, this is the definition is objects or modules should be replaceable with instances of their subtypes without affecting the correctness of the program. So an example of this is ensuring that functions that are designed for bird can also work with subtypes like the flying bird and ostrich without causing errors. So some pros for this: improve reliability. It basically guarantees that subclasses or specific implementations can be used interchangeably without unexpected behavior. It facilitates polymorphism, which basically encourages the use of polymorphic behavior and in a safe and predictable manner. And then finally, it enhances flexibility. So code that adheres to this can be more flexible and easier to refactor and extend. So the first example is going to be a example that violates this LSP principle. So this is essentially the bird actions. It takes in a bird, then it checks if the bird type is flying, then return flying. Else if the bird type is ostrich, then throw new error, ostriches cannot fly. So essentially it's just handling the actions that can it fly or can it not fly. And what we want to do is basically create that, as you can see over here in our example, ensuring that functions designed to work with the type of bird can also work with any type or any subtype. So if it's an ostrich, we don't want to throw a new error. We want to tell the actions of what an ostrich can do instead of it can't fly, basically. So let me bring in the Liskov substitution principle. So if I bring this in just underneath, so this one is adhering to the principle and the other one isn't. So let me just comment this out. And you can see now that the ostrich does not throw a new error because we have ostrich action. So what it's good at is running. So ostrich action is good at running and flying bird actions is good at flying. And then the overarching bird actions basically takes in a bird and then it spits out its actions or its characteristics that it's good at. So let me first of all try the bird actions and pass in the flying action. So bird actions or const flying bird is equal to type flying, and const ostrich is, or should I say const running bird, is equal to the type of ostrich, like that. And then I can call bird actions. So you can pass in the flying bird, which outputs flying, and then you can also do the same for bird actions, but this time running bird, and it outputs running, like that. So essentially, what's happening is the main function, the parent function, it handles everything for us. So in here, we have the birds in here, and this is invoking the bird type. So the index of the bird type, it calls that function. So if we scroll up again, you can see that objects or modules should be replaceable with instances of their subtype without affecting the correctness of the program. And now you can see here that this is the example, whereas this one over here, if it wasn't the bird type of flying, then it would throwing an error. So now this bird actions function below, it takes in any type of bird and it spits out its actions for that bird. So you can see here const flying bird actions, and then this one is the ostrich actions. But essentially what I could have done here is do running actions or something like that. So it's being more specific, and then this one will handle any sub functions or subclasses or subtypes without affecting the correctness of the program. So that is how you would do it. So let's just double check that it achieves what we are adhering to over here at the top in terms of the pros. It improves the reliability, so it guarantees subclasses or specific implementation can be used interchangeably without unexpected behavior. So this is achieving that over here. As you can see, we're passing in the running bird object and then it outputs running because the running bird is essentially the type of ostrich. And then that way we go to the index of ostrich, spits out the ostrich actions, and then that returns running here. So that is fulfilling that. It is facilitating polymorphism, so it encourages the use of polymorphic behavior in a safe and predictable manner, which is what I've explained just now. And it also is flexible, so the code that adheres to Liskov substitution can be more flexible and easier to refactor or extend. So that is the example. Now what I'm going to do is do a React example. So let's do lsp.tsx. And in here, what I'm going to do is bring in my React example that is essentially violating LSP. So again, sticking with the birds idea. So in here, we have a bird component, takes in a bird. So then this basically calls in the constructor method for bird. So bird.fly, and then it returns the bird is flying. Otherwise, it's essentially returning an error message. But essentially, we want to make it so that it's more like this, where we have the actions of the bird and what it can actually do instead of throwing errors. So that's the bad example, which is violating LSP. And then what I want to do is also bring in the good example. So, or the one adhering to this principle in React. So this one over here, what this essentially does is it, first of all, let me just import React at the top. So now we have the bird component like this, that's fine. And each bird has a certain move. So it basically renders the bird is, and then the bird moves. So in our React app over here, we are rendering the bird component. And in our case, the flying bird gets rendered and then the ostrich gets rendered. So on both, we will have flying for this one and then running for this one. So essentially, now we've put it into a component where we've created a reusable component. The bird component handles the move that the bird does. So flying or running in our example, and then this will then render out flying, and this will then render out running like that. So what we've done here is we've created a constructor for flying bird, which is move is returning the flying outcome, and then the same here as well. And then if you wanted to add more methods, you can do as well. So let's do the method for the bird of bird.eats. Let's see what that does. And it eats seeds. And then again, we could do the same here. And again, you can see the ostrich eats insects. But now what we can do in our bird component, we can extend it. So let's copy this. And now we can extend it further. So instead of the bird is, the bird eats. And then we can call the constructor method for the bird. So bird dot, and it's going to be eats like this. Again, if we talk about the other solid principles where we have this is a single responsibility, and also this is now open close, because this now is open for extension and closed for modification. As you can see here, now we can add further methods to flying bird, and we can also add it for the ostrich as well. And also we can add extra bird types as well in here, so like a pigeon or something like that. And then again, that will fall under the flying move and it would eat something different. But now if we render out the bird component, what will happen is this here now. So if we call app or invoke app, should I say, and then the output is the bird is flying, the bird eats seeds, and then the bird is running and the bird eats insects. So let's go ahead and give them a name as well instead of the bird, because we don't know what kind of bird it is. So let's do bird.name like this, and we need to add it wrap JSX parentheses around it like that. And then if we save, what we also need to do now is in here add the bird name. So a flying bird, we could just say the flying bird, and then also we could do the same here. The name is ostrich. So now the output would be a little different. It would be the flying bird is flying, the flying bird eats seeds, and then again the ostrich is running, and so on. So what I'm trying to get at is the Liskov substitution principle is a good principle to have when you can see these pros here of improved reliability, facilitates polymorphism, and it also enhances flexibility. So it's another principle that you should look at and try and implement in your applications. And this one is another favorite that I like as well. So what we're going to be doing next is a very easy one and easy to implement in your projects, which is interface segregation. And we will do that next.